Hello viewers, welcome to the lecture series on basic civil and mechanical engineering. Today we are going to see about refrigeration and air conditioning system under unit number 5. So our lecture about today is about principles of vapor compression system. Let us move into the lecture. So before into the lecture, this slide shows about the mind map of the refrigeration system. So generally there are two types of refrigeration system. One is vapor compression refrigeration system and vapor absorption refrigeration system. That is simply called as VCR and VAR. So you can see the vapor compression refrigeration system. That is about a part of our lecture. You can see here the refrigerant is compressed and through mechanical energy, that is a compressor, and it flows from high pressure to low pressure area, that is to in order to remove the heat, and higher coefficient of performance. And here the refrigerant we use here is freon 12, right? It is dichloro difluoromethane, and it requires of course more maintenance and its operating cost is high, and we can see the diagram in the upcoming slide. So this is about the mind map of the vapor compression system. So why vapor compression system matters? So this vapor compression system is the backbone of the modern refrigeration and air conditioning, also used in the industrial cooling applications worldwide. So why we need a refrigeration, or why we need that system is to in order to maintain the effect of cooling. For example, we need to preserve fishes in supermarket, right? The temperature is very critical in maintaining the medicines, right? In uh, pharma industries, maintaining the temperature of the, what we can say, the medicines, right? The antibiotics and the vaccines, right? So we need to maintain under cool temperature, right? So that is why we need refrigeration. So vapor compression technology ensures the quality, safety and reliability. So in industrial process, it depends upon the consistent cooling and also to maintain the optimal operating conditions. So in the empathy part, we should know what are the needs in the cooling system. So the first thing is the facility managers. So here the facility managers require reliable and efficient temperature control systems that can minimize the downtime as well as the operational disruptions. Right? The facility manager is the first thing here. Right? The facility managers are nothing but our refrigerators. They provide cooling effect. Right? The next thing is about the end user. Of course, the end user are nothing, we are the customers, right? We are the end users, so we need to use the facilities according to the requirement. For example, the temperature should not fluctuate, right? The medicines should be kept in a constant temperature, for example 16 or 12 or 10 degrees Celsius, right? The food should not be spoiled. So these are the end users, food, pharma, right? It should not damage, right? And it should be reliable. That is what the end user, that is what the empathy part. The next is the environmental stakeholder. So coming to the environment, you can see here the environmental stakeholders are the energy. Here the energy should be efficient, right? It should not impact the system, right? Our human system, right? And it should not emit carbons, because carbon footprints are nowadays very important, because we emit more carbons, and the air is in poor quality nowadays, and a human may have breathing issues. So these are the things we should consider while we design a refrigeration system. It should be sustainable, right? It should sustainable. We should consider the future, and according to that only we have to design the system. So this is what the empathy part of the cooling system. So here coming to the topic straight away, our vapor compression cycle. In vapor compression cycle, there are four stages. Let us see one by one. So this vapor compression operates through four interconnected stages. You can see here. The first one is the compression. So here the compressor is used to transform the refrigerant from low pressure area to the high pressure area in the vapor form, right? So what happens is it draws the heat from the particular place. So next is the evaporation. Here only the refrigerant in the vapor form absorbs the heat from the particular area. Then it becomes the vapor, right? That is the liquid refrigerant goes to the evaporation area and it absorbs the heat and becomes the vapor. Next is the expansion. So here the expansion valve is capable of circulation of the refrigerant from the temperature variations from low pressure to high pressure also. Then the next one is the condensation. This condensation is nothing but the phase change. The vapor in the refrigeration, right? The refrigeration effect, the vapor is now condensed into a liquid form. So it converts again into a liquid refrigerant. The cycle again goes repeated. So this is what the vapor compression cycle. Thank you.